All right, so welcome everybody to the first Malware Club meeting of the semester. So for those who don't know me, I'm Odin and I'm the president of the Malware Club. And then Evan is the VP, and then Dr. Brizendine is our Malware Club advisor. So today's topic is going to be an introductory malware analysis with using IDA. So IDA is a malware, and well, it's a reverse engineering tool. Well, a disassembler essentially. So like if you're, I'm sure a lot of you probably already know this, but if you're given like an executable file, like you don't have the source code to analyze, but you can convert it to a readable assembly form, which is not as good as having the source code, but it allows you to statically analyze the program and what's going on. And but before we get into that, you're going to want to create a VApp in. You're going to want to create it like a snapshot in your IA lab. So if you go, you should all probably have you should all probably have a VApp. But the problem is like we don't have licenses for IDA educational unless you're in Dr. Brizendine's CSC 432 class. So if you're not in that class, you'll have to either follow along using the free version of IDA, or you can just watch me for this lesson. So just a little bit about IDA is a little like some good features that IDA offers is like there's a scripting feature in IDA, so you can automate some of the malware analysis tasks using IDA. The good thing about the IDA for the educational or IDA Pro is it reverses like it can has like signature detection for a lot of the Windows APIs. So this helps you a lot in your analysis process. Tyler, we don't really do a sign-in sheet, but I do want to share with you a form. So, and if you signed this yesterday, this is just like the new form for VApps. Eric just wants us to like consolidate a little bit because there are a lot of inactive members of Malware Club. So if you haven't already signed the new form for VApps, I pasted that in the chat. If you could sign that, that way, if we have any new VApps to deploy to you, then we can then we'll have a more active list, so we don't use up a lot of the malware, the IA Labs resources. So I'm going to start sharing my screen, and then I'll show you like what folder to grab the sample in if you're following along with us. I just wanted to reiterate though that we don't have IDA educational in like IDA educational in the club VApp because we couldn't get licenses. But if you're in Dr. Brizendine's 432 class, you can use IDA educational there, or you can follow along using the free version of IDA. So let me share my screen. Okay. So let me just show you briefly where to get the samples for this club meeting. So you go to drive.malware.club. Okay. I think I need to, you might need to authenticate with the captive portal. So there's the sample should be in should be a folder here called meeting January 19th. And you just want to download the malware.zip file. I already have that downloaded. And then make sure, if you have not already, to create a snapshot. I've already created a snapshot, so I'm gonna continue. And then the password for the drive is like usual. It's the same password you use to authenticate to Zoom. So it is it's Malware Club, MALWR Club. So I already did some work in that folder, so I'm gonna extract a new drive. Okay, so first thing we're gonna want to do is open IDA. I'm going to be using IDA Educational. Want to disassemble a new file. And the first malware sample we're going to be looking at is 1.exe. If we have time, we're going to look at these two here and want to do like a little activity to like have you look at a little bit of malware. So, but first I'm going to guide you.
And of course, you
along.
don't want to execute these outside of a VM environment. So only execute the malware in a VM environment.
Okay, so Vivek, I also had, are you using the Windows 7 VM? Because I also had that problem when I was using the Windows 7 VM. But if you use the Windows 10 VM in the CSC 432 VM, then that worked for me. So I would try using the Windows 10 VM. Okay, so I'm gonna want to select portable executable. Oops. All right, so is that a little, can everybody see this okay, or should I zoom in my screen a little bit?
Can you put the Google Drive link again, Tarek? Or not Tarek, sorry, Odin.
Yeah, sure. I can link right directly to it. Hold on. So everybody can see these instructions. I don't have to zoom in more. How does it look, Bramwell?
It looks good. That's the Google Forms. Is that the Google Drive? That's a form.
Hold on a second. Let me click on that. Oh, you're right. Yeah, sorry. I put the wrong link. Oh, it's because it's in the V app, but it's right here. Like Malware Club, and then meeting January 19th.
What's the password?
The password, I'll put it in the chat. It's Malware Club. Tanner, what happens when you try to download the zip file? Oh, and the Malware Club VM, the password for that is password1 exclamation point capital P. Okay, so when you click on this file, it should give you a download option. And then you just click download here. Are you using Chrome? Well, if it doesn't work for now, we'll just have you follow along with my demonstration, and then if you wanted to in your own free time, you could always go back and and look at the malware sample. Well, in this we have like our CSC 432 VM, or in the Malware Club VM, you should have Chrome installed on both of those operating system, both of those VApps. But I'm going to just get started analyzing the sample just so we have enough time. So I'm just going to put the breakpoint right here where we initialize the function here. So I'm going to add a breakpoint, and then I'm just going to create a snapshot right at this moment so I can revert back.
Are you using a local debugger, or what debugger are you using?
Oh yeah, so I'm using IDA. In IDA Educational, there is a debugger that you can use that's built into IDA Educational. Now I'm not sure. Is that also offered in the free version of IDA? Dr. Brizendine, do you know if the debugger is offered in the free version?
I don't think so.
Okay, yeah. So
It could be.
Fortunately, maybe that this will not work if you're using the free version of IDA. But if not, you can just follow along for now with like my screen and just like look statically analyze it. Okay, so this is the function prologue. So it's just starting up a function. So we're gonna just continue along here. So I'm gonna start the malware. And so you do F7 to step into, so that if there are any functions that will step into a function. So I'm going to do Fn and then F8, and then that will allow us to trace the program like one instruction at a time. So we do F8. And then this just this gets a handle. We're not this is just like opens a process. So we're going to continue and see what else we can find, like if there are any other interesting API calls. But actually before that, I do want to, the first thing that I normally like to do when looking at IDA is it offers a few views that I look at. One of them is looking at the strings of I like to look at the strings as well as the imports, because that can give you like some idea as to what's going on in the malware, just like a initial idea. So here you can see this is kind of interesting. This is a registry key. So this is the win logon registry key. And this, if you're not sure like what a registry key is, you can always look that up on the like the MSDN has a lot of information as to like registry as well as Windows APIs. So this, if you're not sure, it's like it allows you to it allows you to run a file upon login. So we'll see later on like why that's used in this malware. We also have Gina DLL, so we can just take a look at what that is. So if we do a little research on that, we'll see that it is called the Graphical Identification and Authentication Dynamic Link Library. So this is a something loaded by WinLogon. So it's related to the authentication policy and interactive logon. So basically what we know is that the malware uses the Gina DLL, which is used for authentication it's an old legacy form of authentication. So that gives us like we can begin to speculate like what this malware does. But we're going to then now look at more into the actual assembly of the code. So we can do function and then F8. So this is just like opening a file, so like opening a process, which is just basically it's setting up something that we'll see as we go along. So although we probably do want to enter this function. So I'm going to set a breakpoint right here. Whenever you see like a function that has like sub and then numbers, that I found that's usually like a function that's defined by the malware author. So I'm going to just restart this. And actually, I believe that will, the breakpoint I have it on will skip like after, we'll get like start after the function. So we actually want a breakpoint that we can start before the function. So you go right click and then add a breakpoint, and then this will add a breakpoint right before the function is called. So we just want to do play. And now play again, and that will jump to the, because we have a breakpoint set here, so we want to jump to the next breakpoint. Let's see. Function F8. Sure. Oh, we haven't. Okay. All right, so now we are at that breakpoint. So we have to do function and then F8, and then function F7 will step into this function. So here we are in the function. So let's just like look around, see what we can find. So here is a function called find resource A. So again, if you're not sure, like that automatically points to me, like tells me that there's probably a resource inside of the executable that it's obtaining, but let's just take a look at what that is. So yes, it determines the location of a resource within the specified type. So a resource is basically normally used to add like text, images, and like things along that line to a PE file, like it's the resource section in a PE file, but it can sometimes be used by malware authors for other purposes as well. So let's set a breakpoint right here. By going, you could also just go run to cursor, or you could do function F4 or right click and then click run to cursor. If everyone could just please mute themselves. I do hear a little feedback in the background. So I'm just gonna continue. So,
And also sometimes Evan or myself may mute somebody if we hear random accidental noise. So don't be offended if we mute you temporarily.
okay, so yes, so this find resource A, and then you see here that EDX is being we're moving the location of a module to EDX. And you can see here, like if you're aware, a little bit familiar with the PE file format, you can see here that this is the MZ header. So this is a PE file that we are loading in. But so it is finding the location of a resource, but like it's looking for that resource, like where that PE file is, and then it's finding the location of that PE file. And this will make a little more sense as we go along here. So let's see like what's happening here with the load resource function. So we can right click and then, well, I find it easier just to do F4 run to cursor, because that will just run to that point. So let's look at the parameters passed in. So this is the H module. So this, if you look here, this is the location of that MZ file that we saw, the PE file that we saw before. And then this, I'm not sure yet what this is, but I think as we go along, we'll figure it out. But basically, yeah, it's let's see what's in EAX. Oops. Yeah. All right, so let's continue here. So it's loading the resource located at this address right here. So it's loading that resource. You also, we could also look briefly at PE Studio, just to see like where that resource is in the file. So PE Studio is used to like show static information. So it can show imports, exports, strings, can show like the sections of the file, and that's what we're interested in right now. So you can see here, there's a resource section. But if you look here, it shows that it's an executable resource with the name of TGAD. And so we see here that the malware is loading that resource into the executable file. So it's loading a PE file into this malware. So we won't need necessarily go into every function, because here it's getting the size, basically the size of it's getting the size of that resource, that section that contains the PE file, and then it's using virtual alloc to allocate that block, allocate a block of memory to that PE file that it just loaded from that resource. So that's what's going on there. So let's continue after that and see what else we find. So we'll just do right click here, and then
Hey, Odin,
yes, Evan.
in the chat, Abdel just asked if you could do that again, please, just that minor section right before the size allocation, I think.
Oh yeah, sure. So let's go back up here. So like before size of resource, right?
Yeah, I think so.
Yeah, sure. So yeah, so it's finding, we're finding, so it's doing the find resource A function, and also it might help to just look at that on the MSDN. So this just determines the location of the resource with a specific name. So let's actually just go back to this area here. So just add a breakpoint, and then we're going to reset. Just step through these breakpoints, and now we're here, like right where it's calling it. So we can examine each of these parameters here. So this is LP type. So LP type is the type of resource. LP name is probably the more interesting. It's like the name of the resource, and then H module is like handle to a module. So this is probably like an address of where that resource is contained, I would think. So here we see LP name is TGAD, like we saw in PE Studio before, like a resource with the name TGAD, and that is the resource that contains the PE file that we were that is loaded by the malware, and then H module, which is loaded into EDX, is the location of that resource. So then find resource just finds that resource, like finds where it is in memory, I guess. So then we get the size of the resource, and then this allocates a block of memory for that resource, like it allocates it in memory so that we can run the PE file that is contained in that resource. So then let's jump below virtual alloc. So we're going to right click and then run to cursor. All right, so let's just look ahead a little bit. So we can see here msgina32.dll. We saw before that it's called Ghidra, is like a authentication, like a legacy authentication DLL used by Microsoft. Like it's yeah, so that's interesting. So we'll probably figure out as we go along, like what that's being used for, but it's right now we see that it's opening a file with this name, msgina32.dll, and it's setting it to the mode is WB, which is write bytes. So then let's go down here a little bit. So let's put our debugger to right here. So do F4, and then let's do F8 to run like step by step, see what happens next in the malware. So this is F write. So this is writing, it's writing bytes to file. So yeah, so this is, we saw here that we're opening a file called msgina.32.dll. So now we're writing bytes into that file. So it'll be interesting to see like what is being written into the file. So if we go here, we can see it's the same file that we saw before, the PE file that was loaded from the resource. So that is what is being loaded by, that's what's being written into this file. So it's essentially what we've learned so far is that the resource is, there's a resource located in the executable, which contains another PE file, and then it's loading that into it's opening creating a file called msgina32.dll, and then it's writing the bytes from that resource, which is an executable file, into this DLL. So it's essentially writing a DLL, like a DLL is what was in the resource section. So it's writing the DLL into the file, and then called msgina32.dll. So now let's continue and see what else we can find in the malware. So F8. So it's just for some reason printing the string DR to the command line. I don't exactly know why that's doing that, but I don't think it's really that important here. So I see a question about process injection, and this particular malware is not actually using process injection, but if we get time, actually we have the next malware, that the malware called chew.exe is actually using process injection. So it will inject a process into a service, and hopefully we'll get to see that next. So in this case, it's a little different like how it's being loaded, but it's actually being loaded from the winlogon registry key, but we'll see that pretty soon. So we'll do F8. Okay, so yeah, msgina32.dll was created by the malware. So this is a file that's created by the malware. There is an actual, like a legacy file called msgina.dll, which is a DLL used for authentication. I think the reason that the malware author used msgina32.dll is probably to confuse, probably just to confuse the malware author. So let's do Fn and then F8. This just frees that resource, that because we're done with it now. We've already written that resource to a file, so we can go back. So now let's see what else is happening. Yep, thank you, Corey. Yeah, that's the link to the MSGina DLL. So let's go down a bit to Fn and then F8. So this is get module file name A. So let's look up what that does. So file name A. So it retrieves a path for a file containing a specified module. So we'll see soon how that's used. But let's for now go down here and right click and add a breakpoint. And then we can just continue to that breakpoint. So here we're moving from the assembly, we're moving this into msgina32.dll. This is the file we just created that the malware just created. So let's go down here. So it's loading this into EDX. So EDX. This contains the current path of the current file that we're in. So when you're looking at malware, as mentioned before, you want to look for like these functions here that are like sub and then the name of the, and then like random numbers. So go right click and then run to cursor. And now let's look inside here, see what that, so we can see it's passing that file name. I think it's of the sample we're in, or is it so it's the passing in the file name that we created, msgina.dll, and passing that into this function. So let's do fn and f7 to jump into this function. Okay, so we can see some interesting activity. So it is creating a registry key. So it's going to the winlogon registry key. So we saw this a little bit before when we were looking at strings, but let's just look a little bit more into the winlogon registry key. So this is commonly used to automate logout, like do automatic logon, so you don't have to enter your username and password. It can also be used to like load a file, like upon login, it will execute a file. So that's what it's being used for here. So let's take a look. Run to cursor. So it's pushing that key here. So then it's creating this registry key. And then you can see here, value name is Gina DLL. So it is adding a new key to winlogon called Gina DLL. And then it is basically it's adding the Gina DLL executable that we created. So let's take a look. So EDX is contained there. Right, so this contains the path of the DLL file that the malware created. So that is being loaded into the Gina DLL key that is created under winlogon. So every time a user logs onto their system, then this DLL will be loaded. So that is essentially what is happening here. Unfortunately, this is more of a legacy authentication, so we can't use like dynamic analysis to see like what is done like with this DLL when we log in. But yeah, there are many malware samples out there that are good like for an introductory like a very basic level. So I used an older malware sample. So this is a legacy authentication method, but luckily this will just allow us to practice our static analysis skills a little bit more and analyze that DLL file statically that was dropped. So let's, I'm going to revert to my snapshot, and then we're going to take a look at that DLL file. Just 1 second. I guess while we're waiting, did anyone have any other questions about any of what I've gone through so far? Okay, so I'm going to share my screen again. Oh, I see a question here. What is a registry key that was created? Are you asking like what the registry key is, or like what a registry key is? Oh, okay. So what a registry key is. So Windows uses you have the Windows registry, which is used for like system components in Windows, as well as software to basically store information about so it stores like user profile information. And one of the registry keys we see here is the Win logon registry key, which can store information. Like it can be used for auto logon, so it could be used for to store like the username, the password for the user, so they don't have to enter it every time. It can also be used to for an executable, like to load a file upon login. So that's what it's being used for here. We also see in malware often that registry keys are used for persistence. So like after you reboot your computer, the registry key loads the like there are like registry keys that will load the load files upon startup. So like when you reboot your computer, so the malware author will set like a registry key to so for when you reboot your computer, the malware file will start up again. So that's a little bit on the Windows registry and like how it's used for malware. So let's look at that DLL file. So we don't want to save this because we're done analyzing it. So, okay, yeah, so actually, I actually have to run the malware for it to create the DLL file. But so this malware won't do anything that will affect my system, so I'm not really worried about running it as of now. So as we see that this malware, this DLL file was created. So let's run startup IDA again. Oops. And take a look at what's going on in the DLL file. So just want to load a portable executable, click OK.
Hey, Odin,
Yes, Evan.
were you meaning to share your screen on this?
Yes, my apologies. So I'll
Okay.
share my screen right now. Okay, so here is the DLL file that was created by the malware msgina32.dll. And so fortunately, like I said before, this is a legacy authentication method. So there's no way of actually, like, we have to statically analyze this DLL file, which is good because that's like the main purpose of this class is to, like this meeting, I mean, this club meeting is to statically analyze malware. So I was just showing the debugger, like that could be another option to make it easier, but that won't always capture all of the activity in malware, because often malware will make use of anti-virtualization techniques, like it can detect if it's in a VM, or it can target specific operating systems. and then you won't get all of the functionality that you won't see all of the functionality that's written inside of the malware. So a good thing sometimes is just to try to statically analyze the malware sample. Sometimes that can take a while, like there could be like hundreds of different APIs in like a normal malware sample. This is just like a simple example just to demonstrate some of the techniques used in malware. We will be looking in a further meeting at like a modern form of malware, probably like a Trojan or a banking Trojan or remote administration tool, and then we can see like how actual like modern malware will function, and you'll see that can be like hundreds of different functions. But for now, let's continue looking at the DLL. So for analyzing DLLs, one thing you could do is like look at the different imports. So or exports, well, actually functions. Let's look at functions. So sometimes I'm gonna save us a little time and actually just show you like which function is I previously identified, which contains the content that we're looking for. But like if you were analyzing this, you probably want to look at like these different functions. Like these would actually like export like the functions that are being exported by this DLL. So either one of them can contain like malicious functionality, but I'm just going to save us some time and point us to the one that contains the functionality we're looking for. So this is WLX logged out SAS. So a good thing, if you're not sure about this, we did previously see that it's making use of the like GINA, which is like a legacy authentication DLL for Microsoft. What's happening here though is like that the malware author created their own DLL file, and then that will in turn attempt to load the MS GINA DLL. So the real DLL is called MS GINA DLL, and the DLL that the malware author created is MS GINA 32.dll, and we'll see how like that's loaded in. But let's just take a look at this, see if we can find any information like maybe on the MSDN just to see like what. Okay, so Weston asks, can certain types of malware hide their processes when looking at them statically? Okay, so Evan did answer that, so I'll
Sorry.
no, that's fine. Yeah, that helps. So we'll continue on. So we'll just look for this online at WLX logged out says. Okay, so this just tells us some information. So this is a function called by when logon, when it received a secure attention sequence. We don't have to go too much into that. But what this does is like when a user logs out or logs in, it will this function will can obtain like certain information about like the user that logs in. Like one interesting thing is that it can collect is, we go down, one of these should have like the username and password. So let's see, forget which one it is, but let's take a look. So yeah, this so this like it passes a structure in, and then it gets one of them contains the domain, username, and password information for the user. So that is was someone
I was
asking a
gonna say,
question?
I wrote some obfuscation code that you can obfuscate function calls and different other things. I think that's kind of what he's talking about with static analysis. Basically, like, okay, so I have a virtual protect function that I'm calling in my malware. I can actually obfuscate that so it won't be detected by AV. I have that code, so if I could upload it somewhere so y'all can, check it out. Just to
Yeah,
kinda-
yeah, that'd be great.
Yeah.
You're also welcome, like, if you ever wanted to present and like show the malware you
Yeah, I can do
created, you're
that too. Either way,
welcome to do that. Yeah.
yeah, either way, I mean, yeah, whatever works. But it's kind of on that subject, because it kind of does exactly what he's talking about, like hides functions basically.
Yeah, yeah, totally. So yeah.
Okay.
Okay, so so this is just gets the domain username and password information. So that's like what this function does essentially here. And as you were saying, Mitch, about like how it's trying to hide functions, like we'll see here, like how it attempts to hide. Like it kind of like it uses a technique where like it goes into the DLL and tries to and grabs this function. We also see like in the another malware sample that it's using like some evasion techniques such as process injection. But let's look here about, so this, as we saw with like the username and domain. So this PNPR notify info is what will contain that information. So let's take a look and see what the malware does with that information. So essentially what we know is that it's grabbing, like when the user logs in, it's grabbing the username, password, and well, it's grabbing a lot of information, but what's particularly interesting is that it's grabbing the domain, username, and password of the user that logs in. So that is saved to the ESI register. And then we can see here that that's being loaded into EAX. And then EAX is being pushed onto the stack. And then we see here a specific string format, which you can kind of infer this username, domain name, password, and I'm not sure what this is, maybe an old password, but we'll continue. So that's what this is doing. So it's getting the username, domain name, and password, and then it's pushing that to this function. So let's take a look at this function. So we see a file name that it's opening here called msutil32.sys, and it is opening that file. So this is a file that is created by the malware in whatever local directory that you're running the DLL from. So then just go, so it's opening this. So let's look for like fwrite or something like that. So here is like a format string, fwprintf. I don't recall what that, I think that might write data to a file. Let's see. Yeah, it writes it to a stream. So that's how the password, username, password is being written to it's being written to that file, msutil32.sys. So that is essentially what this malware is doing. Very simple, but as you see, like it took us a while just to explain those concepts. So like it's just good to like start at a more simpler malware samples and then get more advanced as we go along. So that is it for that malware sample. I am going to I do want to very soon have you look at like just like a few things in a new malware sample. We'll do like a small activity. I know not everybody has the has access to like IDA Educational, but if anybody does, this might be an interesting activity. I'm going to very briefly like look at this exe file. Probably don't spend more than like 5 minutes on it, but just to demonstrate some other malware techniques very briefly. I won't have time to explain like all the granular details, but you're welcome if you want outside of class to look a little further into it and see what you can find. So we see here a new file. It's called inet epar32.dll. And then this existing file, lab11-03. I will tell you that that was the original name of the this 2.dll. So that's what it's doing. It's taking that file and it's copying that to the system32. And then we see here something called cisvc.exe, which is like it's like an indexing, an old indexing like system used by Windows, but it's not so much important like what it's actually used for, but we'll see later why that's used. So let's just look here. So net start cisvc. So it's well here it's copying this to Windows System 32, and then it's starting that as a service, and that. But let's look here, see like. So what it's actually doing is it's injecting it's using process injection. So it's injecting a malicious file into the cisvc service. You can see some of these functions here are commonly used with like process injection. So you have create file mapping A, map view of file. Something else I want to point out very quickly is that it's actually injecting shellcode into the service. So I've kind of just speeding things up here, showing you exactly like where the shellcode is used. If you do see here, IDA just recognizes this as data, but if you press C, then IDA will convert this to code. Click yes, and then this is our shellcode. So this is the shellcode. I don't really have time to look that far into it, but I'm just going to tell you that what it's doing is it's loading this DLL. So the inet epar32.dll that we saw before, it is loading that. The shellcode is loading that DLL, and this is the export that's being used by the DLL. It's just this random name here, but this is now the part that I want you to take a. If you have access to IDA, this is just a part that I want you to look into a little bit. I will start you off a little bit, just show you like a bit of like what to look for. So this is the file that you can for the activity that you can take a look at. So I will do the 2.dll. So want to open IDA educational. Disassemble a new file, 2.dll. And for this DLL, I'd like you to take a look at mostly like the functions that have like sub in them. I'll just show you one here. Maybe try to like look at these. So you have these three functions here. You have where the export starts off. So maybe that's a good place to start looking. But I would look at these three functions here. And then like see what you can find, and then maybe make a determination of like what type of malware this is, and like look at the different APIs, like what's being passed into them. And from there, you can probably determine, like if you do a little research on the MSDN, like what type of malware it is, like what it's doing, like what malicious activity it's performing. I understand this will go a little bit over 8 o'clock. So if anybody needs to leave at 8 o'clock, I completely understand. Otherwise, if you
You
want
mean 7?
Yeah, sorry, I'm on Eastern time zone. But yeah, 7 Central. So if anybody needs to leave at 7, I understand. Otherwise, gonna do like an activity for 10 minutes, and then probably just like for 5 minutes, or 5 to 10 minutes, like go over the results with you, if that sounds good.
Like maybe give people like 5 or 10 minutes to work, and then you'll ask questions and share the answer, basically.
That's it. Yeah, exactly. Probably gonna want to ask some club members like what if they found anything interesting, and then I'll go into I'll briefly go over the results, like what I found.
Okay, so see you in
And
like 5 to 10 minutes then, right?
yeah, and if anybody has any questions, you can I can answer them. And if that's distracting to anyone, feel free to like mute me, and then at 7:05 I'll be coming back.
My dogs were being turds, so I had to go put them out. So I missed. We're just looking at the DLL name 2 and gonna come back after.
Exactly, yeah. So 2.dll, just look at
Okay.
maybe at some of these the functions starting with sub in them, and then we'll return as a group at 7:05 Central Time.
Okay, thanks.
Yeah, no problem. Yeah, if anyone has any questions, you can ask me. Yeah, Tanner, I agree. It's free items. It definitely does not have as many features. I do want to look at Ghidra in the future, maybe for a more advanced malware analysis. Like a couple of meetings, will be looking at some like modern malware. So I probably want to use Ghidra for that, because that I think that seems to offer more features than free IDA. Yeah, I could understand that definitely. But yeah, if you missed anything, I'll definitely be posting the video. So you're free if you are interested and want to see it again. You can watch the video and yeah.
Kind of unrelated to this specific topic, but in malware in general, are you aware of any good Windows tools that are like binwalk on Linux to extract embedded binary objects?
No, I'm not personally. I've not really worked a lot in like Linux malware analysis. Maybe somebody else would. Maybe Dr. Brizendine. Have you worked with that at all?
Binwalk can be widely used to extract various types of things. For instance, if you're gonna go do analysis of an IoT device or some kind of embedded system and you want to get to the firmware, then Binwalk can help facilitate that. All
So
those IoT type devices are going to be in the Linux
You
family.
can use binwalk in Windows or Linux. You just got to use wine. You know what I'm saying?
Now, wine is always an option if you want to have the Windows functionality in Linux.
Yeah, because doesn't binwalk work in Windows?
Binwalk is supposed to work in Windows. I've never had success getting it to work. I've only been able to have Binwalk work on Linux, and there's been times in a Windows environment I've wanted Binwalk without having to just move whatever I'm working with to a Linux VM, running Binwalk and then moving it back to Windows. So that's why I was curious if there's anything you guys know that's like Binwalk that's on Windows, or do I just have to try to figure out to get it working? Because yeah.
There probably is. You probably just have to look into it.
Hey, what's going on?
Hi, we're just doing a activity currently. Probably gonna restart, like bring the group back together in the next couple of minutes.
I think it just turned 5:05 or 6:05 or 7:05.
Okay, yeah, my clock's a minute behind, but I was just curious though, like if everyone could like do the Zoom thing, like where you raise your hand, like how many people don't have access to IDA educational? Like how many people are using IDA free? If you could like do the Zoom thing when you raise your hand. Okay, 3, 4. Okay, so about 4. Yeah, I just was curious to like to plan my next meetings, like what disassembler we should use. I'm thinking maybe Ghidra, so like everybody has a chance. I think Ghidra would probably be better than the free version of IDA. Would you agree?
Any
Like,
of my classes always have the IDA educational, even if it's not the malware class, if you're in any of my classes.
all right, but just like did anyone figure out like what the overall purpose of the DLL is? Anyone want to answer to tell us? Okay, if not, I can go over it with you and show you like a couple of things, and then we'll call it a night. So let's look at where the let's look a little bit at like where. So this is the entry point of the DLL, and so it's creating a thread. Let's go into this function here. So this is potentially interesting. So it's getting a foreground get foreground window. So yeah, so we'll get foreground window and then get window text A. So just doing a little research, it just tells you that that's like it will get like gets the window that the user is currently in, and then it gets like not entirely sure what get window text does. Let's see. Gets the text of the Windows title bar. So it's getting the window and then the text of their title bar. So let's see. Let's look a little further. Get async key state. So what that is doing, so that is something you will commonly see in a keylogger. So this will determine whether a key is up or down when a function is called when the key is pressed. So this basically used to record the user's keystrokes. So that's what that's doing. So it's here, it's like recording all of the user's keystrokes. So that's what that's doing. So it's recording the user's keystrokes. And basically what it's doing is it's writing them to a file. Let's see if we can find more information. So yeah, it's printing those. It's writing these to a file. So that's what the malware is. It's a keylogger. So yeah, so that is that's it for introductory malware analysis. Depending on we'll probably be looking at some more advanced malware next time, like looking at some more, like I said, like maybe looking at like a Trojan or something, just like looking at some more like probably using like Ghidra, but we'll see as but yeah, that will probably be our next topic, like looking at more advanced malware. So yeah, I think that's all I have, but thank you for attending, and we'll see you in 2 weeks. I think
Hey,
maybe,
Eldon,
yes.
you want to ask if anybody has any questions or anything that they want to bring to the floor before we sign off?
Yeah, sure. So, yeah, does anyone have any like questions, closing remarks, or anything?
Yeah, I just had a question. When you were analyzing some of the malware in IDA, I noticed that after the box that you were analyzing that certain part or specific function, two arrows came out of that box. One had a red arrow and one had a green. What do those mean?
Oh yeah, sure. So that's like something that's like the graph view in IDA. So IDA will it's basically telling you the green is if like I think green is if like something is true, so it will like evaluate like a jump. If that like jump is true, it will like go like follow the green arrow. If it's false, it will follow the red arrow. So that's just basically a way that IDA keeps track of like the functionality, like keeps track of like the execution flow of the program, basically. Like
Okay.
it, yeah.
And I also wanted to announce that later on in the semester, Tarek is planning to do a malware creation presentation. And I know his previous one was very well received. And so that is something to look forward to.
Yeah, if there's ever a day nobody's got any ideas, I got something pretty cool I could probably show.
Yeah, we'd definitely be interested. We have been looking for guest speakers. So yeah, I would say I'll put my email, and then you're welcome to email. I'll put all of our emails, and then you can email us.
Yeah, I can show it to you too and see, what you think or whatever. I mean, yeah, I think it'd be pretty informative though. But
I think so too. Yeah, I think that would sounds good. Is it related to like what you were describing with like the malware that you created? I think he left, but yeah, okay. Well, thank you, everyone. We'll see you next time.